Hi everybody. I had a chance to review this week's FlareStar Zoom call yesterday, and it was interesting at the end of the call that there was a discussion of AIJ. So I just thought I would show you how I process data through AIJ and demonstrate some of its features and the power of this particular tool. Okay, so the latest version of AIJ is AIJ version 5.1. There are daily updates or at least very periodic updates to the program from the developer Karen Collins. I actually do some beta testing for Karen on this program, so I'm pretty familiar with the program itself and provide feedback to Karen and her other developers with respect to some of the issues that I've seen in the program in the past, but it's an extremely stable platform. So I'm going to open AIJ, and Karen recommends that you update the program every day, and there's an update function here that downloads the latest version or a little update module. It's quick and easy to do. I won't do that today. So I'm going to look at last night's data. I captured data using my 533 MC, so obviously tricolor data. I've used ASTAP to attach WCS coordinates to each one of the raw image files, and I've also used ASTAP to strip out the tricolor green image, and we're going to open one of those from last night. And I'm sure you guys are all familiar with this particular image if you've been on this star HIP 114066 for a while. Here is our candidate star here, and this surrounding field of view is about half a degree by half a degree, a little over half a degree by half a degree. One of the things that AIJ allows you to do is predefine apertures with magnitudes. These can either be magnitudes obtained from the AAVSO standard stars, or in this case it's a combination of that and magnitudes obtained from the APAS database, because I'm actually using more than the standard stars identified by the AAVSO within my field of view. So I'm going to just import that aperture list. I've got that stored down here. This is my apertures, and here's my target star. This is going to be my check star in the WebObs report. This is the 10.5, 10.5, so 105 as identified in the AAVSO standard star field. And these are some other check star comparison stars that I've selected as well around my target star. And one of the reasons that you want to do this import before you start processing is just so that when you open the data processing unit, it's going to offer you the ability to use the last selected set of apertures, and obviously since I've just brought them in, this will be the last selected set of apertures. So I'm going to close this down. I'm now going to open what's called the data processor within AIJ, and it will immediately open two windows. The first window, you basically put the target name in. You have information about your observatory, your geographic location, etc., etc. And if this information is correct, then this allows for the appropriate calculation of timing and air mass and stuff like that. So this is one of the input screens. So this is set up correctly. And the second part of the second window is the CCD data processor window. And within this window you can go to your hard drive and select the folder where you're gonna look for the data to be processed. And once you've done that, you can select one of the files. And once I modify the file name up here, I can then select all the files that were collected last night on this target star. Now, if you have not done your bias, dark and flat at this point, this area here allows you to select your master darks, master flats, master bias. I actually do my darks and flats on the fly when I capture the images, and so my raw images are saved with that already done, so I don't need to go and do this. And I've got all my files selected. I've got the appropriate checkboxes checked here, and essentially what this is saying is with this checkbox selected, it's going to allow me to do a multi-aperture photometry run, and I'm going to click start. And this is, I guess, one of many setup windows that comes up, or that comes up during using AIJ, but it's broken into a number of fairly easy to understand areas. You can either select fixed apertures, or you can select an aperture based on the first image, or you can use variable apertures from image to image, and I actually choose to use variable images these days. And one of the reasons for that is if things are changing slightly, seeing maybe my telescope is getting colder and the focusing's changing a little bit, and so consequently the light from the star is either tighter or not so tight, depending if the focus is moving a little bit. The use of the variable aperture compensates for that. I've selected use the previous 8 apertures that I just showed you a few moments ago, and position the apertures using the RA and DEC coordinates, which are already associated with the FITS header of these images. So I'm now going to click place apertures, and you can see that my apertures have come up. The colors, these are my 2 target stars, if you like. This is the actual target star, this is the check star, and these are the comparison stars. And now that these are placed, I can simply hit return, and it will start doing the differential photometry. And this was the measurements file, or this is the measurements file that was discussed a little bit on the Zoom call. It's being created one row at a time here. There's about 700 raw images to process. And if I scroll across, you can see that it does indeed include many columns, and the number of columns becomes more and more dependent upon the number of comp stars that you use and whatever data you choose to save. Now, the good news is you don't actually have to look at this measurements file at all once you've got your workflow set up. So albeit it's a fairly intimidating data file, you don't actually have to go and look at it row by row or column by column. As you can see, it's taking probably less than 1/4 of a second to process each image on the differential photometry. This is basically a Chromebook, so it's not a very powerful laptop, and you can see that we're going to process about 700 images here in probably 5 to 10 minutes. So I'm actually going to stop it at this point because obviously we don't want to just watch this going ahead while it's doing all of these images. I'm just forced a hard stop there. So anyway, once that got to the end of the processing of the 700 images, I would have saved that measurements file. So I'm now going to open the measurements file, or a measurements file that I created earlier. And this is the associated measurements file. And like I said, it does contain many columns of information, and some of it's quite useful if you want to start doing certain types of analysis. Anyway, we don't really want to do that today. What we want to look at now is what my data looks like. So having created the measurements file, which took about probably about 10 minutes, I'm guessing, we'll now open the plot file, or the plot function on AIJ, which will delve into the measurements file and plot our target star and our comp stars. And I think this is one of the intimidating things about AIJ, is that when it goes into its plot function, it throws up a multitude of windows. I would strongly recommend using AIJ on a multi-screen PC rather than a single PC screen as I'm using at the moment, because there are a number of windows, and it's actually helpful to have some of the windows open on one screen and some of the windows open on the other screen. But because I can only record one screen at the moment, I'm going to just keep it all on one screen. This is one of the main control windows within AIJ for the plotting function. It's called the Multiplot Y data function. And essentially you can think of this as a template. I have preset this up. So I've got some rows in here that allow me to display up to the relative flux curves for up to 8 stars, including the target stars and the comp stars. I've got a line item in my template that allows me to show you the air mass, and I've got a number of rows here that allow me to show source minus sky for each one of the stars of interest. So this one is after these here are after the differential photometry has been done. This is the data before the differential photometry, so this is basically integrated ADU count. And you can also then display other things such as magnitude, etc., but I find that this is basically all I need. So the first thing I'm going to do is I am going to deselect the differential photometry results and look at the raw data coming in with the air mass. And when I do that, you can now see the data I collected from last night. So these are the integrated ADU counts for each one of the stars over the course of the run. You can see where I did a meridian flip, and actually at the point of doing the meridian flip I also reset the gain of the camera, because this run here the gain was a little high. It wasn't saturating, but it was higher than I would have liked, so I lowered the gain a little bit, and that's what's caused this jump in ADU count. And you can basically see here that the target star, which is here, the check star, which is in red, and the comparison stars all basically are doing what we expect. As the air mass increases, the ADU counts drop, and the relative flux plots are pretty stable. If, for instance, one of these was showing some big dips or something, then you know that there's been some sort of systematic error with that comp star. If you saw some variability, and this one is actually varying a little bit, so that's 5. You could perhaps decide that you're not going to use 5 based on looking at this, but you can see that my target star and my comp stars are all pretty stable here. So now I'm going to go back to my Multiplot Y function, and I'm now going to select the relative flux after the differential photometry has been done on the data, and I'm going to turn off. And once you've got this template set, you don't need to change it. Again, it seems kind of intimidating the first time you come across this template, but once you've actually set up your templates and you understand what checkboxes to check and what not to check, you can it becomes very straightforward to use. So I'm now going to go back to my plot. And so here is my plot now. I can see my differential photometry for my target star, I can see my check star, and I can see my comp stars. Now, if I feel that any of these comp stars are bad, I mentioned a minute ago that perhaps T5 and T7, but certainly T5 had a little bit of variability in, I can switch these on and off. And this changes the plot according to which particular comparison stars that you've decided to use, and it updates the plots, and if you want to, you can then resave the measurement table once you've decided on your final ensemble of comparison stars. So I actually decided in this particular run that C5 and C7 were varying a little bit too much for me, so I'm actually going to switch these back off again, and it was this set of measurements that I saved. One of the other things that you can do, I can quickly mention here, is if you see that there are spurious data points, perhaps a cloud went over and caused some problems, you can actually go in and you can press Shift, and you can go in and you can, for instance, if I felt that this was a spurious data point, which it probably isn't, I can click on it and remove the data point, and then if I save the measurements table, it will save the measurements table without that data point included. Okay, so I've got my run from last night. As you can see, there were no flares, unsurprising for this star. And all I need to do now is generate my file to upload to the AAVSO. Okay, and to do that, I simply go into the Multiplot main window, which was another window that was thrown up during the plotting process. I can go File, Create AAVSO Variable Star Report. I can fill in all of the appropriate data here, so my observer code, the target star, the check star, which in this case is T2, the catalog magnitude for T2, its magnitude error, what filter I'm going to upload data for, etc. So I have done that, so I'm going to press OK. This is all set up correctly, and it's going to ask me to open the measurements file that I just created a few minutes ago. I'm going to do that, and it's immediately created the AAVSO report, and that can be found back in my directory. Okay, grab it here. Okay, there it is. And there is the AAVSO report that I can now upload to through WebObs. And as you can see, the entire process is extremely quick. I'm able to process a filter or a run for one of the chosen filters in probably about 15 minutes from beginning to end using AIJ. Okay, well that's the end of the video. Hopefully that demonstrated to you just how quick and powerful the tool is. I've been using the tool for about 2 years. There have been a lot of new features added recently, which makes it even more powerful. The AAVSO reporting function is new. There's also a automatic comparison star picking utility, which I'm still undecided on how well I like that at the moment, but I'm sure over time that will get to a point where it's extremely functional. Karen Collins monitors the AIJ forum on a daily basis and does a fantastic job of getting back to people and chasing down bugs, etc., etc. And if any of you have got any questions relating to the use of AIJ, hopefully I can help you answer them. So I will say bye for now, and I will post this video to YouTube.